Well, we're going to do this question here that says write the following without the root sign. Okay, meaning before doing that, I would like to write the law here. One of the law of exponents still says like when you have like the nth root, okay, this is written, you read this, the nth root of a to the power of m. This is equal to a to the power of m over n. Okay, so we can apply this formula to solve these problems. Now, question 1, for instance, here a says like the fourth root of a to the power of 6, the fourth root. So this, following the formula, it may be like a to the power of 6 over 4, which is equal to a to the power of 3 over 2. Okay, and then b says the third root of x to the power of 5. This will be x to the power of 5 over 3. And then c, c is the square root of a to the power of 5, following the formula. Okay, when you don't see the symbol, as I said, the symbol here, understand this is a square root. So this will be written as a to the power of 5 over 2. And then d says the fourth root of x to the power of 3. This will be equal to x to the power of 4 over 3. And then e is the cube root of a squared. This will be equal to a to the power of 2 over 3. Okay, and then f, the square root of x. The square root of x. This is just like x to the power of half. Okay. Well, when we are doing question 1, we gave this rule for the law of exponent. We say that the nth root of a to the power of m equal to a to the power of m over n. Okay. Remember, those laws of exponent formulas are useful forward and backward, okay, from left to right as well as from right to left. So like in this question here, we'll have questions in this form, but we need to write it in the square root form, in the root form, okay. So let's start with a. Question A says that a to the power of 4 over 5. Understand that the denominator is the indices of the roots, so it's going to be like the fifth root, and the numerator will be the exponents of the base a. So that's the fifth root of 4 to the power of 4. No, the fifth root of a to the power of 4, I mean. And then b will be the sixth root of x to the power of 1. I don't need to write the power of 1 because it's just 1. C, there I have like a to the power of 5 over 2, a to the power of 5 over 2. Over here, I can just write the symbol, the square root symbol, and then a to the power of 5. And I don't need to write the indices 2 there, because the symbol itself, the root symbol without any indices, indicate that it is a square root. D, x to the power of 2 over 3. There, we're talking about the third root of x to the power of 2, and then e. So e, a to the power of a half is just a square root of a, square root of a. We write like that, and then f, x to the power of 3 over 2 is just the square root of x cubed. Okay, thank you. Well, we have another question here, question 3, that says simplify the following without using a calculator. Okay, I'll move this a little bit up there. So question A, it is say that the third root of a to the power of 4. So you know, this can be written as 8 itself is a cubic number, so it's like to the power 4, and then third root there, and then 8, I'll say here 2 to the power 3, okay? So this can be written as, in the radicand, okay, within this, the radical sign, we can convert that to 2 to the power of 12, okay? Because over here, we times the exponents as we did. And then this will be equal to 2 to the power of 12 over 3, and that makes 2 to the power of 4, and this is equal to 16. Okay? And then for question B, we have, like, it says 32 to the power of 2. The 10th root of 32 to the power of 2, this is equal to, we're going to convert 32 in terms of its prime factor. 32 is like 2 to the power of 5, okay? And let the 10th root, and then this will be the 10th root of 2 to the power of 10, okay? And then remember that, okay, when the indices and the exponent are the same, they can just cancel each other, okay? The root and the exponent will cancel, and then the answer is just 2. Okay, and then C says cube roots of 27 squared, cube roots. So this will be 27 is 3 cubed, and then that was the cube root. So this will be then, okay, that was my 3, this is a 3. It is 3 to the power of 3. So this will make cube root of 3 to the power of 6. So this will be then 3 to the power of 6 over 3. And then the answer here is just 3 squared, which is 9. That was C. And then we can also do D. Okay, I need to move it up there. This is the square roots of 1 over 4 to the power of 3. Okay, so 1 over 4 is also a square because it's like, okay, let me write like this, the power of 3 there. 1 over 4 can be written as 1 over 2 squared, okay? And then 1 on its own is also a square number, okay? So we can write it like square root of, I don't want to write with, okay, this will be square root of 1. No, I want to use square bracket here now. Of 1 over 2 to the power of 2, all to the power of 3, okay? Because the numerator and denominator share the same exponent, I can write it like this, I have to the power of 2, and then it was the power of 3, that's why I put square bracket here to the power of 3, to negate the power of 3, and then this will be equal to square root of 1 over 2 to the power of 6, okay, and then this is equal to a half to the power of 6 over 2, and then this is equal to a half to the power of 3, and then that's equal to 1 over 8. Now, I need to make you notice that this can be also done this way, this other way. We could write a square root of 2 to the negative 2, okay? When we had like 1 over 2 squared there, we could write like that, and then this is raised to the power of 3, okay? And then this will be like square root of 2 to the negative 6. And now we say, what is square root of 2 to the negative 6? We cannot do because we have a negative. No, careful. Yes, we can do. The negative here is not on the base, okay? It is on the exponents. Yes, we can do this. This is 2 to the power of negative 6 over 2, which is equal to 2 to the negative 3, which is equal to 1 over 2 to the 3, which is equal to 1 over 8. If you're unsure, check this in the calculator. Check square root of 2 to the power of negative 6, and then hit the equal button. You got 1 over 8, okay? Question E. Question E says cube root of 0,125 to the power of negative 2. Okay, what's that? This is like cube root of 125 can be written as 1 over 8. Okay, so in fraction form, it is like 1 over 8. So it's like 1 over 8. Okay, to the power of negative 2. And then when the power is negative like this, we can transform that into we can write it like 8 over 1, but I don't need to say 8 over 1. I can just say 8. It's like 8 to the power of 2. Okay, and then 8 is cube root 8 is 2 to the power of 3. So this will be cube root of 2 to the power of 6, and then this will be 2 to the power of 6 over 3. And then that makes 2 squared and equal to 4. Okay, F, we do have like square root of 2. Okay, let's see the question again. F, it's square root of 2 all to the power of 4 over 3. Square root of 2 all to the power of 4 over 3. So we can write square root of 2 is 2 to the power of a half. Okay, all to the power of 4 over 3. So here we're going to times the exponent. It's going to be like a half times 4 over 3. And then we can simplify this 2 with 4 there, and then we're left with 2. And this is equal to 2 to the 2 over 3. Okay. So which can be simplified into this is just the denominator is the indices, and then the numerator is the exponents. That makes a cube root of 4. Okay, and then h h was okay, 4th root of a squared times a squared times root of a. So here we have like the 4th root of a squared multiply by square root of a. So this will be like a to the power of 2 over 4 multiplied by a to the power of a half. Now this is the product we know. When we have same basis, we add the exponent. So this makes a to the power of 2 over 4 multiplied by plus a half. Okay, and then this will be a to the power of 2 over 4 plus instead of me writing a half, and to change it into 4. So I times here by 2, I times here also by 2. So that makes a to the power of 2 over 4 plus 2 over 4. I mean, yes, 2 over 4. And then this equal to a to the power of 4 over 4. Okay, which is just a to the power of 1, which is a. Okay. I could have made it simpler from here because, 2/4 just makes a half, okay? So a half plus a half is the whole 1. So 8 to the power of 1, okay? What we have for I, that's x to the power of 1/4 multiplied by x to the power of 2/8 all to the power of 3/8. 3/8 all to the power of 2. So this will be like x to the power of a quarter multiplied by x to the power of 3/8 multiplied by 2, and the exponent like that. So we can simplify this and that, and then we left with 4 there, and then that will be x to the power of a quarter multiplied by x to the power of 3/4. Now this will be x to the power of a quarter. Because the bases are common, we're just going to add the exponents. So a quarter plus 3/4, that makes a whole. So x to the power of 1, which is just x. Okay. And then j. This is square root of 8x to the power of 6 all to the power of 4. So this will be I'll solve it differently. We can break this root. So it's going to be like square root of 8 multiplied by square root of x to the power of 6 all to the power of 4. Okay. Square root of 8 is like, that will make open bracket square root of 2 to the power of 3 multiplied by square root of x to the power of 6 is like x to the power of 6/2 all to the power of 4. And then that makes 2 to the power of 3/2 multiplied by x to the power of 3 all to the power of 4. And then that makes what? 2 to the power of 3/2 multiplied by 4 times exponent multiplied by x to the power of 3 times 4. And then there, this 4 and 2 left with 2. That makes 2 to the power of 6 x to the power of 12. Okay, that's the answer. Well, we can also do it this other way. From here, we can make 8 is a cube number. So we can say 2 to the power of 3 times x to the power of 6 can be written as x to the power of 3 to the power of 2. Okay, we can write x to the power of 6 like that. Or we can say x to the power of 2, okay, to the power of 3, like this. So the fact that all to the power of 4, so the fact that the exponents here are common, okay, we can combine the basis by saying x to the power of 2x squared to the power of 3, okay, all to the power of 4, right? Now, even the power of 4, okay, and then this one will be like 2x squared to the power of 3/2 multiplied by all to the power of 4. Now, 4 and 2 here will be simplified, left with 2, and then this makes 2x squared, okay, to the power of 3, to the power of 6, sorry. to the power of 6, because we times 3 with 2 there, and then that makes 2 to the power of 6, x to the power of 12. Okay, thank you. Now, we're going to do question 4 here in exercise 4. The question says simplify as far as possible and leave your answers in positive exponential form. Now, question A. Here says what? Square root of 0,04 raised to the power 5. Okay, so this will be 0,04 can be written as in a fraction form, so it's like 4 over 100. It's like 4 over 100. Okay, to the power 5. I say that because when the comma is here, we can move the comma one time and twice. So 4 over 100 to the power 5, and then this can be written as square root of 4 is a square number. 100 is also a square number, so it can be like 2 squared over 10 squared. Okay, to the power 5. Now, this is like saying I prefer to introduce the square bracket here because I want to do this because exponents of the numerator and the denominator are common. We can write this within the brackets to the power of 2. So there we have like 2 over 10. Okay, and then close brackets to the power of 5. Now we can apply our law of exponents here where we can times these. Okay, and then we could also cross these roots and then the power of 2, and then say the answer will be 2 over 10 to the power of 5. We can do that, yes, we can, because okay, let's see, this is still okay. We can do that. We can cross the power of 2 with the square root, and then this will be just equal to 2 over 10, which is 2 over 10, which is 1 over 5. Okay, and then B. Question B says 8 to the power of x plus 1 multiplied by 2 to the 1 minus x all over square root of 2 to the power of 4x minus 2. Now, in this case, I will prefer to write 8 in terms of its prime factor. It is, okay, we have like x plus 1 times 2 to the power of 1 minus x all over square root of 2 also. I'm going to write it in terms of its prime factor. So that now let's 8 in terms of prime factors is going to be like 2 to the power of 3. Square root of 2 in terms of prime factors in exponential form, I mean, will be, 2 to the power of a half. Now, this will be equal to 2 to the power of 3, open bracket, x plus 1, multiplied by 2 to the power of 1 minus x, all over, over here also will times a half of everything there. It's going to be like 2 to the power of a half times 4x minus 2. Okay, so this will be 2 to the power of 3x plus 3 multiplied by 2 to the power of 1 minus x all over 2 to the power of 2x minus 1. Okay, because we times a half by 4x, that makes 2x. A half times -2, that makes -1. Now, now that's all. We have bases of negative of 2. Bases are common. We can just write over here the 2 there to the power of 3x. Okay, plus 3 plus 1 minus x. We combine, okay, the exponents here and the numerator. Now we're going to minus this with the 1 at the denominator to x minus 1, okay? And then this will be equal to 2 to the power of what? 3x plus 3 plus 1 minus x minus 2x plus 1, okay? And then this makes what? 2 to the power of, we can do 3x and negative x and negative 2x. All these 4. And then 3, 1, and 1 there makes 6. So that makes 2 to the power of 6, which is equal to 64. Okay? Excuse me. Now we can also do question C. Question C is given by cube roots of 27x to the 6 plus square root of 81x to the 4 minus fourth root of 256x to the 8. Okay, so now over here it's like I can break this. It's like cube root of 27 multiplied by cube root of x to the power of 6. The rule says that root of a b, mth root of a b equal to mth root of a times mth root of b. Okay, so we can split it like that. So this also is like square root of 81 times square root of x to the power of 4 minus fourth root of 256 times fourth root of x to the power of 8. Now cube root of 27 is just 3, and the cube root of x to the power of 6 is going to be 6 over 3, plus square root of 81 is 9, times fourth root of, square root of x to the power of 4 will be 4 over 2, minus fourth root of 256. I know that 256 is 2 to the power of 8, okay? So it's going to be 2 to the power of 8 over 4 multiplied by x to the power of 8 over 4. So this makes 3x squared plus 9x squared minus 2x squared multiplied by excuse me, not 2x squared, but 2 squared multiplied by x squared. So that makes 2 squared is just 4. So now 3 squared plus 9 squared is 12 squared minus 4 squared is 8x squared. Okay, that was question B. C. Now we're going to do D. Question D says 4 over 9 to the power of negative 3 over 2. So in this case, because we have a negative exponent there, okay, according to the law, it means that we can write it with a positive exponent. So it's going to be 9 over 4 to the power of 2 over 3. Okay? Excuse me. To the power of 3 over 2. Okay? Just the exponent becomes positive. Okay? Now, 9 is a square number, so is 4. So this can be written as 3 squared over 2 squared, okay, to the power of 3 over 2. So this can be written also as, I can use the square bracket here because I want to write 3 over 2 to the power of 2, okay? All over, all to the power of 3 over 2. We can do that. We can write when the exponents are common for the numerator, and the denominator we can write this in this form, and then 2 here and 2 will be simplified, and the answer will be just 3 to the power 3 over 2 squared, which is 27 over 4. Okay. Question E now. It is given that 81 k to the negative 2 all to the power of a quarter multiplied by k to the power of a half all over 27k to the power of negative 1. Now, you know, 81 is, in terms of its prime factor, is 3 to the power of 4. So here we can say this is just 3 to the power of 4 multiplied by k to the negative 2 all to the power of a quarter multiplied by k to the power of a half all over 27 is just 3 to the power of 3 multiplied by k, okay, to the power of negative 1. Now they say that the whole thing is raised to the power of negative 1. We can switch it, so we can move it up, okay? So this with a positive exponent following this law that says 1 over a to the negative m, just writing the law, this is equal to a to the positive m. So this is gonna be like the power of 1 over 4 is for each term here. So this will be like 3 to the power of 4 times a quarter times k to the negative 2 times a quarter times k to the power of a half times 3 to the power of 3 to the power of k to the power of positive 1 now. Okay. So this can be just written as 3 because here and there they can be simplified, this and then simplified. We're left with negative 1. And then this will be like k, 3 times k to the that's 2. So 3k to the negative 1 over 2 multiplied by k to the 1 over 2 times 3 to the power 3 times k. Okay. So when we combine these two, that makes 3 times k to the power of negative half plus a half makes 0 times 27. Let's just leave it as 3 to the power 3 k, and then that makes like here we have some base, the power is 1, so we're gonna say 3 to the power 4 because 1 plus 3, 4, and then 0 plus over here also the power is 1. 0 plus 1 is just 1, so 3 to the power 4 k1, k to the power of 1, which is just 81 k. Okay. Now question F, which is given by square root of 8 times 2 to the negative 3 all to the power of 4 all over 64 to the power of negative a half. Okay. Square root of 8. 8 is 2 to the power 3. Okay, multiplied by 2 to the negative 3 to the power of 4 over 64. Okay, I prefer to move 64 to the negative a half to the numerator, becomes like 64 to the positive a half. Okay, and then this will be then 2 to the 3 over 2 multiplied by 2 to the negative 3 all to the power of 4. 64 can be written as 2 to the power of 4. Not to the power of 4, but to the power of 6. And then this makes 2 to the power of 3 over 2 multiplied by 4, multiplied by 2 to the negative 3, negative 12, multiplied by 2 to the 3, okay? Because we times here. Let's say 6 times a half. Now we can simplify 2 with that makes 2. This with that makes 3. And then that makes 2 to the power of 6 multiplied by 2 to the power of negative 12 times 2 to the 3. And then we just want to write 1, 2, and then we add the numerator, the exponents. Okay, that makes that, and then this is equal to 1 over 2 to the 3, which is equal to 8. Sorry, 1 over 8. 1 over 8. Okay, thank you. Well, we have another question here that says, without using a calculator, simplify the expression 4 to the power of 3 over 2 plus 8 to the power of a third minus 0.5 to the power of negative 2. Now, we can write this one as 4 to the power of 3 over 2 plus 8 to the power of 1 over 3 minus 0.5 to the power of negative 2. So now let's transform them, okay? 4 can be written in terms of a prime factor, which is 2 squared. 8 also 2 to the power of 3, and then 0.5 can be written, 0.5 is just a half, and then a half in exponential form can be 2 to the negative 1. Now, here we times the exponents, right? 2 and 2 will be simplified, 3 and 3 will be simplified, and then, negative 1 times positive times negative 2 makes positive, so that will have like 2 to the power of 3 plus 2, okay, minus 2 to the power of 2. 2 to the 3 is just 8, plus 2 minus 4, and then this equals to 6. Thank you.